Okay, let's go ahead and talk about our third conic section, which is ellipses. So if I have a cone and I take a plane and I cut through my cone kind of at an angle, and I don't go through the base, but I just go right through the cone from one side to the other. And so if I were just to cut it off right there, I would wind up with a shape that looks like this. And so in elementary school you learned that this was an oval, but its correct name is an ellipse. And so that's our third conic section. So let's kind of review the different ways we cut through the cone. We talked about in the first section, if I cut, so if I had a plane like this and if I cut down through the base, I would get, when I cut that piece off, I would wind up with this parabola shape. And so that's where my parabola comes from. If I took a plane and instead of cutting at an angle like this, if I cut parallel to the base, exactly parallel, of course the base of a cone is a circle, and so I would get a circle. And it kind of looks oval shaped from here because I'm looking at it from the side, but it would be a perfect circle here. And then we have one more section we'll talk about, and we'll look at how to cut that and produce that section as well. But that is one of the things you have to remember. So our objective here is to be able to sketch graphs of elliptical conic sections to relate the parameter changes with ellipses to the changes in the graph. And our language objective is to use the visual support that we have here to help us understand the vocabulary. So we'll begin, and this should be the title of the page that you're working on is Graphing Ellipses. And we'll work through this kind of in sections. So first of all, the working form, and there's another name for this other than working form, we also call this standard form. So we'll kind of use those things interchangeably. Sometimes we'll call it standard form, you might see it called working form. And I think on one of your papers, it abbreviates that as SF. And so SF is just standard form, it just means get it into this working form. So, kind of like circles, we're going to start out like circles. We have the x minus h squared, but this is a little different here. Well, we gave this form actually when we looked at circles, but it's going to show up differently with our ellipses. And y minus k squared over b squared equal to 1. So this is standard form, so I always want my equation in this form for graphing, because if it's not, I can't find my center, so I can't graph it. And my center will be the same. And center in this, the concept is a little different. It's still HK, but when we think of the center of a circle, then it's the center of everything. Same distance here and here, same distance here. With an ellipse, it's the center across this way and then the center across that way. So it's that intersection point of the two kind of what we would call diameters, I guess. The horizontal distance. So from the outside edge here to the center of the circle, and then from the center to this outside edge here, is found in your denominator of your x term. So horizontal, x-axis, this is our h is horizontal change, so that's the horizontal distance. This whole section here is all about everything horizontal with my ellipse. And this section here is going to be everything vertical with my ellipse. Okay, so horizontal distance is going to be found in the denominator, and so we will take the square root of whatever number is there, and that will be our a term. So this is squared, notice? So you'll see when we write the equations that we'll have to square our a. And then the vertical distance, of course, is on the other side, so it's the square root of b squared, or just b. Okay, so let's see how that works then. So we're going to mark our center point here, marked right here, and we're going to do, the coordinates of that are 1, 2. So there is my center, 1, 2, and that is H, and that is K. And we can find A by just counting. So from the center out to the very edge, right here, is 5 units. So A is 5. And B is, you could go up or you can go down, but B is 3 units from the center to the edge vertically. And then we're going to write an equation for this in standard form. So x minus h squared over 5 squared. And 5 squared is 25, so you can write that as a 25. For this particular one, I'm going to graph it also, so I'm leaving it in this form, and you'll see why in a minute. Y minus k squared over b squared is equal to 1. So this should be my equation, so we're going to go to our calculator and look at how to graph our ellipses. So on a graph page, again, we'll change this. We're going to change the way that we enter this. It's an equation. Specifically, this is an ellipse. And I only have one option here. This is standard form. And so, things to notice, there is a minus already here. So if I want this to be a plus instead, I have to enter a negative number here. And then here's where I was saying you would see in a minute. Now in the bottom, they already have squared, so you can't put 25 there because it will square it. You have to put 5. So we want x minus 1 squared over 5 squared. So x minus 1 squared over 5 squared. And y minus 2 squared over 2 squared. And enter. And there is our ellipse. And I'm going to come back to this a little later and show you also. I'm trying to move that, not to forget on it, so just take it in. I'll show you later when we come back to this how you can actually use your calculator to analyze this and find several different parts of the ellipse as well. Okay, so I need this center here, which is at -4, 1. My A value is from the center out to the edge here, so my A is 1. My B value is from the center either up or down, so my B value is 4. And notice even if I went to the left right here to find my A value, it's still a positive 1, even though I went in a negative direction, because I'm talking about the distance from here to here, and so distance is not going to have a negative value, it's always positive. So x minus, now if I was trying to graph this, I would put minus a -4 in the calculator, but if I'm just writing the equation, I just really want to change that to a positive 4. And so the general rule, just to kind of help remember this, is that if you're putting it in parentheses, the sign changes. If you're not putting it in parentheses, the sign doesn't change. Now this is over 1 squared. So I'm going to write, if you were graphing, you would write it like this. But when you are just seeing the equation, so I want to prepare you for everything for the way you would normally see it, and it would be correct to see it this way, is that we know any whole number where we don't have a fraction, it's actually over 1. So in this case, if your denominator is 1, you're not going to put anything there. So with the same respect, if you see an equation and there is no denominator and you're trying to graph it, you need to remember that that's a 1 there. Plus y minus k, so y minus 1 squared over 4 squared, or over 16, is equal to 1. Always equal to 1 in standard form. Okay, and then I also want to look at one that has a center of 0, 0. Okay, this is my H, this is my K. My A value, I'm going to count all the way out to the edge, and that is 6. And my B is 2. Okay, I'm going to write it here the way you would have to put it in the calculator. And we do want to take the time when you write an equation to graph it, and make sure it matches up with what you intended it to be. So I would have x minus 0 over 6 squared plus y minus 0 squared over 2 squared equal to 1. Now that's for graphing purposes, works with the calculator. That's not how you're normally going to see this written. Here's how it would normally be written. X squared over 36 plus y squared over 4 equals 1. So when you see a numerator with nothing but your variable here, then your h value is a 0 or your k value is a 0. Whereas if you see no denominator, it was a 1 that they didn't write down, because we can't leave a 1 off. I'm seeing a lot of confusion in class over this. I can't leave a minus 1 off. I can leave a minus 0 off. I can't have a 0 down here in my denominator. That would be undefined. But I can leave out a 1. Just divide by 1 would not change anything there. So this would be a center of 0, 0, a value of the square root of 36, or 6, b value of the square root of 4, which would be 2. We're also going to look at how to graph from the equation. So here's my equation given, and this is the same as what is on your page. So I'm first going to identify my center, and so this is x minus h, so there's my h, and y minus k, so this is my k. And remember, we need to remember that this minus is just part of the formula, so my h value is actually a positive 3, and my k value is actually a negative 2, because minus a negative became positive. So my center is at 3, negative 2 right here. To find the a value, again, a is horizontal, so I'm looking with all of my horizontal numbers here. So a is the square root of 16, which is 4, which means from my center I'm going to go out 4 units to the right and 4 units to the left. And we'll go ahead and write down those points. So that's at 7, negative 2, and at negative 1, negative 2. We're going to do the same thing with b, so b is the square root of 36, or 6. So from my center I'm going to go up 6 units, and I'm going to go down 6 units. So those points are, so that's at 3, 4, and 3, negative 8. Okay, and then we're going to sketch this, and we're going to try to make it look kind of oval-shaped. It seems like no matter how I turn this tablet, it just does not work well to make a rounded shape. So much easier on the smart board. Anyways, something to that effect. Yeah, not bad at all. Anyways, make yours look better than mine. More rounded than that. Yeah, okay. And that's basically how we're going to graph our ellipses. Alright, so you can pause right here and go ahead and complete pages 2 and 3 of that practice page, and it's the same thing. Everything is going to be either graphing from an equation or writing an equation from the graph. Then we're going to look at the final page, the back page of that. And so this goes back to our parabolas, because if you think of an ellipse, you have to kind of think of it like it's one parabola facing inward here, and another parabola facing inward here. So it's two parabolas kind of opening towards one another. And when we looked at parabolas, we talked about focus points, how this is a point inside the parabola that my parabola is kind of focused around. And as far as parabolas go, you can't really call it a center, but that's the best I can say, is that it's focused around that. And we also talked about the directrix, which was a line that the parabola was moving away from. And so the parabola is always the same distance away from the focus as it is from the directrix. So here we have two parabolas, which means that we now have two focus points, and they're both going to be located inside the ellipse, or inside the vertices. We still have vertices here, of our ellipse. We also have a major and a minor axis. And so major just means the larger. So if my ellipse is longer horizontally, then the major axis is horizontal. Where if my ellipse is longer vertically, the major axis will be vertical. And so then the minor axis would be the smaller. And this is similar to the idea of a diameter. Your axis is basically a measurement from one side of the ellipse to the other side, and one side of the ellipse to the other side. So formula we can use is that the major axis in this case is 2 times A when it's longer horizontally. When it's longer vertically, the major axis is 2 times B. The minor axis is 2 times B when it's a horizontal ellipse, and 2 times A when it's a vertical ellipse. We are also going to use this formula to help us find our focus points, or plural of that is our foci. And so C equals the square root of the absolute value, because this is distance, it has to be positive, of A squared minus B squared. And then we use that C value to find the focus points. And those change. The C formula doesn't change when it changes from a horizontal to a vertical ellipse, but the formula for finding your focus points does change. So we're going to practice. We'll practice one. No, let's see. Yeah. We'll go through these algebraically, but then I'm also going to show you how to analyze and find those points. So, things I need to know to find the major and the minor axis. I need to know what A and B are. So A is the square root of 36, which is 6. And B is the square root of 4, which is 2. And on this particular one, I could also count and see that it's 6 from here to here, and it's 2 from here to here. So for this particular ellipse, the major axis is going to be the distance from right here to all the way over here, or 2 times A. So that's going to be 2 times 6, which is 12. The minor axis will be the smaller axis, and that's going to be 2 times B, or 2 times 2. So it's 4 units from top to bottom. For our focal length, so we're using this formula, C is equal to the square root of the absolute value of A squared, so 6 squared, minus B squared, and we're going to go to our calculator for that. So we need a calculator page. So square root of, and then absolute value bars, remember, are right here, and our absolute value bars. So 6 squared minus 2 squared. And so we're going to round this to the hundredth place, so we're going to use 5.66 for our focus point. So C is equal to 5.66. Okay, so then to find the focus points here, I also need to know H and K. So my center was 0, 0. So H is 0 and K is 0. So focus points horizontally on this, because the focus points are always on the major axis. And so I wouldn't want to find these ones there on the minor axis. So I'm looking at here. So my focus points then are changing horizontally. So it's going to be H plus my C will give me 1 point. So that's going to be 0 plus 5.66 is 5.66, and then the K is 0. So this is H plus C and K right here. And so I can plot that point. So that's going to be somewhere approximately right here, inside, right on the inside of that vertex. And then I'm also going to do my H minus C. So that would be a negative 5.66 and then 0. And we can plot that point, and that would be right over it in here. So those are my focus points. So let's go ahead and graph this on the calculator and look at how to analyze and find those using our calculators as well. The graph page. And again, I'm going to change that to conic. And so this was just an x squared, so we have to put a 0 in there. And again, we don't want to put 36, we're putting 6 squared y minus 0. And we don't want to put the 4, we're going to put 2 squared. So A and B. And we're going to graph that. And so this was the ellipse that we just looked at. And we want to move this out of the way so we can see real clearly here. So just like we analyze any other function, we can analyze the graph. And we're going to go all the way down here to analyze conics. And so we can choose several different things on the ellipse. We're going to be working with these three right here. And so you have a whole page of practice where you are finding center vertices and foci. Now before it will show up, you have to come click on your graph. So my center is at 0, 0, and I will just repeat that for the rest of my conic features or characteristics here. We can find the vertices, and again I have to come and actually click on my my ellipse before my points will show up. So I have a vertex at negative 6, 0, and then one at 6, 0, and no, that didn't work. Analyze, and I'll find the foci. And move those out so you can see them a little better. So we rounded ours off to 5.660 and negative 5.660, but those are the foci points, and then these are also the vertex points. And you can see then it also plotted those focus points right here. And it is just inside the vertex points, which is what we had shown also on our graph here. Okay, again here my center is at 0, 0. My A value here is going to be the square root of 9, or 3. My B value will be the square root of 25, or 5. So for this, because my ellipse is longer vertically, it's going to be 2 times B for my major axis, or 10, and 2 times A for my minor axis, or 6. So here, this one is why you really need the absolute value signs with your formula. On the last one, it wouldn't have made any difference, but with this one, if you don't use the absolute value signs, you will get a negative value, and that's an imaginary number, and so that just doesn't. Alright, so square root of 3 squared minus 5 squared, square root of the absolute value of, let's go right back here, square root of the absolute value of 3 squared minus 5 squared, and enter. And so 4 is what I'm working with here. So C is 4. So now this time I'm not changing H because my major axis is vertical, so my focus points are going to be on that major axis, so they're going to be somewhere right inside those vertex points. So my H value won't change. My K value, I'm going to add C, and then I'm going to subtract C. So I have a focus point right here, and a focus point right here. And again, you can graph this. You can find those points using analyze graph, analyze conics as well. Alright, so go ahead and make sure you complete everything in the graphing pages, and then we're going to look at completing the square for ellipses so that you can complete the second assignment over ellipses. Now, most of the assignment you can use your analyze graph, analyze conic. So finding your center, finding your vertices, finding the foci, you can do that using the calculator. Things you'll have to do on your own for sure. There's a few questions where you're asked to find the major and the minor axes, and then you're going to have to get everything in standard form. So we're going to work with completing the square. So our steps are a little bit more complicated than they were with the circles we worked with last time. Some of it's the same, though. We're going to begin by grouping x terms and y terms on the left side of the equation, for the most part, and constants on the other side. This one is different, though. In the circles, everything that we did had an a value of 1. And so what we're looking at here is problems that don't have an a value of 1, so we're going to have to factor out that a value for each group. So it's most likely going to be a different a value for the x's than it is for the y. And then we're going to complete the square. So this is the same. We do our b over 2 squared, add that to both sides, except that you'll see when we work them out, there's one thing to watch for here. We'll factor and write it as a binomial squared or simplify. And then this is new. I think we kind of looked at this in circles, but for these they have to be equal to 1, so then we'll take our constant and divide everything by that constant in the end, and then we'll be able to identify the center and our a and b values. So let's look at an example here. So step 1, we're going to group together things that go together. So I have x squared minus 6x. Now those were both already on the left side, so there shouldn't be any change in the signs. Plus 49y squared and 196y. And then our constant is going to move to the other side of the equal sign, which means it is changing sign. So we're going to start with this. So that was step 1. Step 2. We're going to factor out the a value that's not a 1. So for my x terms right here, let's go ahead and group those. For my x terms, a was 1, so I don't have to do this for my x terms. It's ready to go. I can complete the square with that group. For my y terms, I'm going to factor out 49. Which means factor out, remember, means that I'm dividing each of these terms. But here's the most common mistake I'm seeing is that we're forgetting to divide this term by 49. So that leaves me with y squared here. And then this, I believe, is going to be 4y here. Equal to negative 156. Okay, so that was step 2. Factor out the a value for each group. Alright, so we're going to complete the square. And so that means b over 2 squared is going to be added to both sides. So step 3. So on this side, here's my b value right here. So I'm going to add b over 2 squared, so negative 6 divided by 2 would be a negative 3, and negative 3 squared is 9. I'm going to do the same thing here, so I've got a 49 out here, and that's just going to carry all the way down. Y squared plus 4y, and so that's my b value here. So 4 divided by 2 is 2, and 2 squared is 4. So that is 4 right there. So this is the b over 2 squared, this is b over 2 squared, equals negative 156. Now here's where you've got to be a little careful of what you're doing. Over here, all I added was 9, so I'm adding 9 here. But on this side, I didn't just add 4, because if I distribute this back through here, which I will have to do in the end, it's really what I did here. I just pulled it out, so it goes with this. So I actually added not just 4, I added 49 times 4. So I need to make sure that that's what I add on this side as well. Okay, so then step 4 is we're going to rewrite these as binomials squared and simplify. So that basically means that right here I'm factoring. So a times c is 9, b is negative 6. I want factors that I can multiply together and get 9, and add together and get negative 6. So that is going to be x minus 3 twice. Plus, this is just going to carry on out there, 49. I'm going to do the same thing for my y values. So a times c is 4, b is 4. So I can multiply 2 times 2 and get 4. I can add 2 times 2 plus 2 and get 4. So this is going to be y plus 2 twice. And we're going to simplify right here. And I'm going to have to add plus 9 plus 49 times 4. So we're adding 49 to both sides. I'm sorry, we're simplifying, and that's 49. Alright. So we rewrote at each as a binomial squared. We simplified. So we are right here. This was the other thing that was new. I need to make that equal to 1. So I'm going to divide everything by whatever my constant is. So this is going to be x minus 3 squared over 49 plus 49 times y plus 2 squared over 49 is equal to 49 over 49. And we're going to go ahead and then simplify anything. So by simplify, I mean reduce your coefficient here with your denominator here. So in this case, I actually have a 1 out here, and I cannot reduce that down anymore, so this one is going to stay the same. So x minus 3 squared over 49. Which is okay, because this is my a squared right here. Plus, now this one will reduce, so I've got 49 over 49, which reduces down to 1 over 1. So I have y plus 2 squared over 1 equals 1. Okay, I now have standard form. So I can find my center. So my center is going to be 3, negative 2. I can find my a value. A is going to be the square root of 49 or 7. B is going to be the square root of 1, which is still 1. And then I can tell what type of conic this is. So if this number turns out to be the same as this number, when I have done everything, I had a circle, because that means that it goes out the same distance that it goes vertically. So horizontal and vertical would be the same. If these numbers are different, then it's an ellipse, more of an oval shape. And so this is an ellipse, and I can tell specifically that since my a value is bigger, that my major axis will be horizontal, and so this will be longer horizontally than it is vertically. So we're just going to call that, call it a horizontal ellipse, just to differentiate it from one that would be longer vertically. Okay, let's look at one that has a values that are not 1 in both cases. So both my x terms and my y terms have a values that are not 1. So the first thing again I'm going to do is group together my x terms and group together my y terms and move my constant to the other side. So you notice the only thing that changed sign here was my 111, because that's the only thing that actually changed positions in my equation. Everything else was just, I just regrouped it on this side. It was already here. So I'm going to factor out 16 here. So I have x squared minus 4x and I'm going to factor out 25 here. So I get 25 is y squared plus 6y is equal to 111. Okay, let's go ahead and do our b over 2 squared. So here's my b. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Same thing here. Y squared plus 6y. Here's my b. 6 divided by 2 is 3, and 3 squared is 9. Alright, so then this we have to take into consideration too. So I'm adding 16 times 4, and I'm adding 25 times 9. Alright, so this carries down, and we will go ahead and factor here. So we come up here. A times c is 4, b is negative 4. So my factors are negative 2 and negative 2. So I've got x minus 2 twice, plus 25. We'll factor here. A times c is 9. b is 6. So 3 times 3 is 9. 3 plus 3 is 6. So I've got y plus 3 twice. Equals, and I'm pretty sure this comes out to be 400, but let's double check that. 111 plus 16 times 4 plus 25 times 6. Yep, I was wrong. 325. Did I put that in there? No. No. I didn't. There you go. Yeah, I thought that was 400. Okay, so equals 400. Alright, so then our final step is we're going to divide everything by 400. So 16 will go into 400, so I'm going to reduce this down. I reduce 16 over 400 and it will be 1 over 25. I'm going to reduce down 25 over 400 and it becomes 1 over 16. And so I could write my 1 out here, but we really don't need to do that. Equals 1. So the center here is at 2, negative 3. My a value is the square root of 25, or 5. My b value is the square root of 16, or 4. So this again is going to be a horizontal ellipse because it's longer horizontally than it is vertically. Okay, one more example, and then I'm just going to let you try some. In this case, I don't have a b term for either of these, so if there is no b term, I'm not completing the square. And so you'll see some examples where, for let's say, you only have an x squared term, and then you've got a y squared term and a y term. So you would only be completing the square for your y's in that case. In this case, I'm not completing the square for either, but I do need to get this in standard form. So I'm going to put my variable terms on one side and move my constant to the other side. And I need it equal to 1, so this one is really a pretty easy problem. I'm just dividing everything by the constant. So 81 over 324, I need the x squared, and I'm pretty sure that reduces down to 1 over 4. That reduces down to 1 over 4, so I've got x squared over 4 plus, and then this one is going to reduce down to 81. These always work out so nicely, unlike the real world. So this is my standard form. So the center is at 0, 0, because there was no h term here, there was no k term here. So 0 is the only number that I could have just not written down. A is the square root of 4, or 2. B is the square root of 81, or 9. And this would be a vertical ellipse. In other words, it would be taller than it is wide, because my B value was larger, and my major axis would also be a vertical major axis. Alright, here's a couple for you to try. If you have problems with these, please message me and we'll work with these a little more then. And then on your second assignment, the one over ellipses, the first thing that you have to do for your problems before you do the analyzing is that it says SF, which means you need to get everything in standard form. In other words, in this form where it's set equal to 1.